So this is geometry section 2.8. Okay, it's on lines, and they are called linear equations, but we're going to focus on lines. We'll get to the linear equations in a little bit. There are three kinds of lines that we deal with. There are oblique lines. Okay. There are horizontal lines, and there are vertical lines. Okay, so those are your three lines. Okay, the oblique lines are, if I do a x and y axis, oblique lines are like this. Okay, all right. So an oblique line like this has a positive slope. And we'll get to slope in a minute. And then one like this has a negative slope. And all lines are defined by their slope. So oblique lines have a positive slope or a negative slope. All right. A horizontal line looks like this, and its slope is 0. All right.
Is it like, would it have to be 0 or 1? Because,
You can't do that.
but 0 or 1.
0 or 1 is the same as 0.
Oh.
Okay? Then a vertical line, if I draw an x and y axis, is vertical, and this has no slope. And I'm gonna, it's no slope. It's not no solution. It's not 0 slope. It is no slope. And the difference between the two is, I always say, you know, if I say how many elephants are in the room, you say 0. If I say how many unicorns are in the room, there's no such thing as a unicorn. Okay? So there's a difference. This has no slope. All right. So these lines, I'm going to talk about slope in a minute, but these lines have three forms they can look like. The first one is capital AX plus capital BY equals capital C. Do you remember the name of this form?
Standard form.
Standard form. I call it tuxedo form because it looks really nice, but it doesn't do a thing for you. Okay. The second one is y minus y sub 1 equals m times x minus x of 1, and this is called point slope. And what are the two things that you need to have in order to use point slope?
2 points.
A point and slope. Hence, its name is point slope. And the last one, this is the subtraction sign, if you couldn't see it from over there. And the last one is y equals mx plus b. And this is slope intercept. So these are the three forms. Most generally, the book will ask you to put something in slope intercept form or standard form. This is tuxedo form, Carly. This is what I call blue collar. Blue collar is the working guy. He's the one that does all the work. He's your offensive lineman. Okay? And then the slope intercept is your graphing. It's what we use to graph. So those are your three forms. I don't know if you remember them or not, but I hope you do, because it'll make this go a lot easier. Okay? The horizontal line, by the way, the domain and range of an oblique line is all real numbers. They go on forever, both left and right and up and down. A horizontal line, the slope is 0. It has one form. And that form is y equals some number. Okay? So y equals 6, y equals -2, y equals 8, whatever. It's just y equals. And so when they ask you to put something in one of these forms, and it's a horizontal line, the only thing you can put is y equals equal. Y equals some number. This is all three forms. It serves as all three forms. And this one then would be x equals some number. X equals 4, x equals 5, so this might be x equals 3 because it's over here at 3. This might be y equals 1 because it's up at 1. You see what I'm saying? All right, you remember all that?
Yeah.
All right, here's our three different lines. You can see that all of them are based on slope, aren't they? So slope is really important. So we need to understand slope. All right, so let's begin with it. Slope. Its definition, I say, is rise over run. Okay? It's a change in y over change in x. What do you notice about this?
It's a fraction.
It's a fraction. What else do you notice?
Y is first.
Y is first. Y is in the numerator. That just blows students away because they graph a point. They go left and right first, and then they go up and down. And here we're going up and down first, okay? Some people write it like this. Oops. I say that, and then I use x, right? Y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. The sub 1s and sub 2s means there's different x's. Right? So this is slope, rise over run. All lines have slope, except for vertical lines. So these lines have a positive or negative slope. This one has a slope of 0, and this one has no slope. So it's all based on that. All right? Now, if I draw a line up here, I'm going to turn this. Can you turn it so it stays a graph? Okay? No.
Got it?
What did you do?
Nope, I got it. I just zoomed in.
Be careful. I want you shutting her off.
I wasn't.
So let's say I just go like this. I pick this point and I pick this point, and I draw a line between them, and I say, all right, what's the slope? By the way, I'm not real excited about the lines that they put on your paper because they don't have arrows on them, and that's ridiculous. I'm not sure why it was. It's a great worksheet. That's the only problem I have with it. So let's take a look at this. Well, one of the ways you can do it is you can just count. Oh, what's the letter we use for slope?
X.
Yeah.
Oh.
It's the number in front of x, so it's this one and this one. In standard form, you can't really tell the slope. Okay? I'm going to show you how, though, real quickly. All right? So what happens is I'm going to look at this, and I'm going to find m, which is slope. And I have 2 points that I can clearly see that the line goes through. And so I'm going to grab those 2 points. What I'm going to do is I'm just going to go from one to the other, and it's rise over run. So I'm going to start with this one, I'm going to go to this one. So rise is up or down first. So how do I get from here to here? Well, I go which direction? Down. So that's a negative. So it's 1, 2, 3, 4. So m equals a negative 4. Over, now I'm here, right here. So I go left 1. Over a negative 1, so my slope is 4 over 1, which is 4. I do not like you to put 4 over 1. I want 4. Yes?
What if you went, I guess, never mind.
Okay, so let's go the other way.
Yes.
I'm going to go from this point to this point. So I'm going to do my rise first. I go up 1, 2, 3, 4, up 4, and to the right 1. And those are both positive. I get 4 also. It doesn't matter which point you start with and which one you end up, you will always get the same thing. Yes, Addie?
So, like, if the line was continuing on and it clearly went through a point, but there's not a point there, can you count to that one or not?
Yes, if they don't put a point on there, yes. If you can see it clearly goes through the corner, yes, yes. Okay, now, that's one way to find. So on the first several, all you gotta do is count over there, right? Now you can see, they put points on, they put 2 points on there every time. Now make sure you simplify your slope. Harper, what did I just say?
Make sure you simplify your slope.
Thank you. Make sure you simplify your slope. Now let me give you another way to find slope using the change in y over change in x. This point here is 3, 3, correct? And that point there is 2 and negative 1. So all I do is take the change in x over the change in y. So I do change in y over the change in x. Did I say it backwards? Okay, I don't remember. So 3 minus negative 1. Now, if I take this one minus this one, I have to take this one minus that one. It doesn't matter what order you go, as long as you stay in the same order. Okay? So 3 minus 2. So I have plus a positive, so that's 4. Plus a negative, that's 1, so I have 4. I got the same slope, didn't I? Did you see that?
Uh-huh.
All right. So I'm going to say, find the slope of each. Find the slope. What do you think the most common error is?
Y over rise.
Y over X or
X is over Y's. Yep. Would you find the slope between these 2 points, please? Let's just use one of theirs. This is an odd, so you're not gonna do it. Find the slope between those 2 points. It's number 11 on your worksheet. And you can put it on there if you want to have an example to look at. So Greeley, which one did you begin with?
Negative 20 minus,
You gotta do y's first on top.
14 minus,
15,
yes.
and then negative 20 minus 17, right? So I got a negative 1 over a negative 37, right? Is that considered simplified?
No.
Yes.
No.
37, or 1 over.
1 over 37, you have to make them both, if they're both negative, it's a positive, right? Okay, you see how to do that?
Yep.
Alright, so what happens if I do this, find the slope of this? Y equals 5 halves x plus 8. What is the slope? 5 halves. What if I put 5 halves x?
It's 5 halves.
What's that?
Still be 5 halves, wouldn't it?
Nope.
Plus
You cannot put, it's 5 halves, you cannot put the x with it. The x has nothing to do with slope. But I have students that do that. Okay? I have students that do that. You okay? So what would happen if I did this? 2x plus y equals 4. How do I find the slope of that one? Say,
Isn't it negative 2?
yes, but how do you get it?
Because you do y, you have to, y equals.
Okay, you have to solve for y. Very good. So I have y equals, and I bring this over here. When I bring it over, it becomes negative. And so my slope is a negative 2. You see how that works? Notice how I put it in front, because it's been in slope-intercept form. Questions about that? Okay? All right, let me tell you something else about slope. Can you turn this a little bit so we go over it? Okay? Parallel lines have the same slope. Parallel lines have the same slope. So if one of them is, if you have 2 parallel lines and one of them has 2/3, the other one has 2/3. Perpendicular lines have slopes that are opposite reciprocals. Now, I'm going to give you a chart to kind of help you figure this out. Okay, so in my chart, here's my slope. M, here's parallel, this is a symbol for parallel, this is a symbol for perpendicular. Did you know that?
Yep.
Alright, so what I'm going to do is I'm going to give you a slope. Let's say my slope is negative 2/3. Okay? What's a parallel line slope? What is it?
2/3.
Nope,
Oh, it's negative.
negative 2/3. Alright, now the perpendicular. Dawson,
Negative 3 halves
nope,
or 3 halves.
3 halves. It's the reciprocal
Yeah.
and it's the opposite. You got it? Alright, so I go, 5 is my slope of my line. CJ, what's parallel
5.
and what's perpendicular?
Negative 5.
Yeah.
Negative 1 over 5.
Negative 1 over 5. You see how that works? Okay? So on the next page, on page 2, when it says find the slope of parallel line to 13, alright? the line there is 2/3, so what's your line, the parallel line to it, what slope would it have?
2/3.
2/3. Now go 15, it's perpendicular, so what would be your slope on 15 of a perpendicular line to that, Kyle? Number 15. Are you with me, or are you not even with us? So. (15) perpendicular. Perpendicular to that line would have a slope of what? The slope is a -1/2. What's the opposite reciprocal of a -1/2?
2.
Positive 2. 2/1. Actually, just put positive 2. Then the next one says, sketch the graph of each line. What do you notice about those lines?
They're oblique.
They're oblique, and in what form are they?
Oh.
They're in slope-intercept form. Make sure when you sketch these that you do it with arrows on it. Okay, so I'm gonna have you move it over, but here's the line. Okay, we're gonna sketch this. Number 4, y equals a -3/5 x plus 2. Okay, let's take a look at this. In slope-intercept form, this is the slope, correct? What do you call this? B.
It's the,
The y-intercept.
It's the y-intercept. Hence, it gets its name
It's on the y-axis.
slope-intercept. So if we look at this, this is my y-intercept. You actually graph that first, which is kind of a pain, but we graph this first. So we're gonna graph 2. So I'm gonna go over here, and it's on the y-axis, correct? So we're gonna graph 2, so we're gonna go up 2. Does everybody remember that?
yeah.
All right, so we're gonna graph 2, and then my slope is a -3/5. So from this point, negative means I go down. 1, 2, 3, and 5 is positive, so I go right. 1, 2, 3, 4, 5. And I have 2 points there, and I put the line through it. And I put arrows on the end of it, and I'm done. You see how to do it. That's why it's called the graphing form. It's because you can graph it very quickly. Now you can also graph lines by their x and y intercepts, right? What's an x and y intercept? Shoot me over here again. What do you think an x-intercept is?
When it crosses the x-axis.
Where it crosses the x-axis, that is correct. Can you tell me then, Jaws,
Mhm.
what is the y value at an x-intercept? If I'm touching the x-axis, this point right here, see where it touches the x-axis? What's the-
0.
At 0. Okay, so what do you think a y-intercept is?
Oh, why?
Y-intercept, what is a y-intercept? That was an x-intercept, what's a y-intercept?
Where it crosses the x-axis.
Where it crosses the y-axis.
Axis,
Alright,
yeah.
so on this one, it would be right here. And what is the x value at that point? 0. So the x and y intercepts are the places where it touches the x and y axis, and the other value is 0. Okay. So if I tell you that an x-intercept, we're going to sketch, the x-intercept equals 3, and the y-intercept equals a -4. Okay, how would I sketch that? I'm gonna have you turn, Josh. To sketch that, I would go, the x-intercept is 3, so 1, 2, 3. That's where it touches the x-axis, and then the y-intercept is a -4, so 1, 2, 3, 4. That would be down here, and that's my 2 points that I need to graph a line, and I have her done. Now it's wonderful if they give you the x and y intercepts, but if they give you an equation, that's not so bad. Wonderful. All right. Could you turn it? So let's say I still want to sketch, but I have 3x plus 4y equals a -12. Now I have an equation in what form? Standard form. One of the ways I could do it is I could simply solve for y and put it in slope-intercept form, correct? Right? That would be great. And then I could just graph the y-intercept and, all right, but I'm gonna teach you a quick little method, especially in this case, of the x and y intercepts, all right? You told me, Jaws told me, that the value of y was 0 when x is touched, right? So what if I just put 0 in there, all right? And this is called a t-table, and I would go 3x plus 4 times 0 equals a negative 12. So I put 0 in for y. So hark, this is 0, correct? So I have 3x equals a negative 12, I divide by 3, I divide by 3, and y equals a negative 4. So I have 1 point at a negative 4, 0. That's my x-intercept. I do the same thing to find the y-intercept. So I'm going to put 0 in for x, and I'm going to go 3 times 0 plus 4 times y equals negative 12, and 4 times y equals negative 12, divided by 4, divided by 4, y equals a negative 3, so there's my 2 points. Now, are those the only 2 points that I can put in? Yes, Bo.
Where does the 3 go? Don't we have to subtract it?
This is 0.
Oh,
Anything times 0 is 0. Okay, I'm just, yeah.
Why on the one above it, why did it say y equals 2?
Y equals negative 4 because I put 0 in for, oh, yeah, it should. Yes,
Speak Farley, please.
okay. You got the assignment? Okay, all right.
Uh-oh.
Good luck.
She's in trouble.
So, yes. Now, I want you to, I think you could put something in for anything. I could put 57 in for y. That would be nuts, but you can do it. But watch, I can put 1 in for 4, or excuse me, for y. So I'm gonna put 1 in for y. So I have 3x plus 4 times 1 equals a negative 12. So I have 3x plus 4 equals negative 12. This is a little harder because I still got a number, don't I? I just subtract and I get
Negative 16.
0. I get a negative 16. I get 3x equals negative 16 divided by 3. And I get x equals a negative 5 1/3. Correct? So negative 5 1/3. Now let me show you something. The reason I did this was I'm going to graph this line, right? Would you turn the camera? I'm going to graph this line. I'm going to show you that they all work. Doesn't matter what I put in. 0 is way more convenient than putting 1 in, isn't it? But I can put this in negative 4, 0. Negative 4, 0, 0, a negative 3. And 1, a negative 5 1/3. 1, 2, 3, 4, 5, and 1/3. Wow, that's not on that point. What did I do wrong?
You went down 5 and 1/3 instead of 4.
Yeah, you
Oh, never mind. Thank you.
We still
I can't see it from here, so it's a negative 5/3 1. So 1, 2,
Oh,
3, 4, 5, and 1/3 1. There we go. Thank you. I couldn't see it. So yep, there it is. Notice all 3 points are on that line. And there you go. Now, how many points determine the line?
4, 2 or 2.
2. So I don't have to find 3, but if you want to check it, go ahead and find 3. All right? Okay. All right, so now I'm going to give you some lines, and you're going to tell me what the equations are in slope-intercept form. All right? The first line is this one. Okay, take a look at this line, and I want it slope-intercept form. Okay, so that means y equals mx plus b, correct? Y equals, well, find my slope by using 2 points, right? Up 1, to the right 3. So that slope is
1 over 3.
1/3 x, right? The slope is 1/3, and 1/3 x. Plus, where does it touch the y-axis?
Negative 2.
There you go. There's your equation in the slope-intercept form. If I wanted to put it in standard form, I'd have to multiply everything by 3, move this over, and put it in standard form. Okay, so let's erase that one. Okay. give me the equation of this line in slope-intercept form.
Y is 0.
Y equals 3.
Yeah, oh, okay.
Cause it goes.
Zero
Up three.
slope.
It's because there's zeros.
So horizontal line, y equals 3. This works for this form, and this form. So the terrible twins actually are kind of nice, alright? Once in a while. Here's the other twin. If you want to put it in any form, it's x equals what?
1.
Negative 1.
Negative one.
And that is a vertical line, alright? Okay, we're gonna stop there today. You may shut her down, Jaws.